Hello and welcome to the channel. Today we're going to do something a little bit different than we have in the past. We're going to go ahead and we're going to call the Weare API and build a custom connector experience around it inside of Power Automate in order to go ahead and monitor our barbecue. Let's go. So today's a big football day, which means it's time to barbecue, grill, watch the games. And today the Arizona Cardinals are taking on the Houston Texans. Arizona hasn't lost a game yet, so we'll go ahead and we'll see how well they do today. Now, Weare, in terms of this, it's something I've purchased, I guess, a couple months ago. And I know this video isn't sponsored, but hey, just let me know if you want to sponsor it. And it's actually a pretty cool device. What it does is it's a meat probe. You basically stick it into the meat, and you will get notifications and alarms when basically your threshold hits. So for example, I need to wrap this brisket at about 160, so I need to know when the temperature hits 160 so that I can go ahead and do that. And so something I've learned by getting in barbecue this last year is that cooking by temperature is so important. And so that's why I decided to get one of these devices. Now, the Traeger that I'm using today doesn't have Wi-Fi, and that's part of the issue here. When you do have Wi-Fi, Traeger's got a pretty good app that'll go ahead and allow you to control the temperature on your unit itself, plus go ahead and create alerts and alarms so that you can stay on top of this. I don't have that in the Traeger that I'm using here today, and so this is going to give me similar telemetry in terms of like temperature alarms, that sort of thing. But the challenge is this is going to use Bluetooth, and it uses Bluetooth in order to go ahead and to communicate with their app. Now, their app's pretty good, but the problem is your phone has to be close to the barbecue because that's where this thing's going to live. This is kind of the brains of it all. It's going to sync up with the pen, and then in turn it's going to sync up with your phone. Now the problem is the range, I would say, is not as great as it could be. And so if I'm, say, upstairs, I will lose connectivity with my barbecue. So what I figured is, hey, let's see if there's an API, and sure enough, Weare has put something out on GitHub, which is cool, and I'll show you that here in a little bit. And so now what I can go ahead and do is leave my phone near the barbecue, and I can go ahead and working on my laptop upstairs, and then get notifications using Power Automate and the whole connector suite. So today what I'm going to do is I'm going to build in an orchestration that's going to monitor my barbecue. It's going to have specific milestones. Well, it'll send me notifications inside of Microsoft Teams, and then I'll know exactly when my barbecue is ready and go ahead and wrap it. So that's kind of the essence of today's show. And so now what I'm going to do is I'm going to go ahead and just put this into my meat, get the meat on the grill, and we'll take it from there. Okay, so here we've got a 7-pound brisket, and I've gone ahead and inserted the Weare meat probe into the meat. We can see that we've got a flashing green light, which means we're in good shape. Now, this is a 7-pound brisket, and what I've done is I've added some olive oil and then some rub from Meat Church. So Holy Cow and the Gospel. It just doesn't get any better than this, in my opinion. Now I've got it on the grill itself. Currently just have it on 165 with the smoke setting. I'll do that for about an hour. Then it'll be time to turn it up to 225. Okay, so the other thing that I wanted to chat about is this is the Weare app, or at least a screenshot of it. And so what ends up happening is once you've been able to sync your phone with your device, and you've got your meat probe and you've got basically your meat on the grill, you can go ahead and establish a cook. And Weare's pretty cool about this. Like, they will basically have a whole list of different types of meat, and then different cuts of meat, and then sort of different styles of cooking it. And they'll give you guidance on it. So for example, I had indicated that I'm going to cook a brisket. And so they said, hey, you want this to be like fall apart meat. And so with that, you need to hit like 200 degrees plus Fahrenheit for that to happen. And so what I've done is I've gone ahead and selected beef brisket and said, yeah, I want it to be fall off the bone. And then what will happen is it will go ahead and sort of give you an estimated cook. Now, not quite reflected. It does take probably, I'd say, half an hour of cooking or so for it to then sort of figure out how long this is going to take. I'd say it's pretty accurate. I think there's a big difference between when you have your meat wrapped and not wrapped, but it's kind of a good signal. I kind of like it. And then what it's also going to show us here is any alarms. So I can go ahead and add more alarms. What this is going to do is give me an alarm 5 minutes before the cook ends. Now with brisket, you do want to wrap it at around 160 degrees Fahrenheit. So I'm going to go ahead and add another alarm, or actually that's what we're going to do with the API. And then what we can do is, start to monitor it from that perspective. So you can also do it where you're focused on like your grill. So if sometimes you're concerned about your grill losing heat, especially if you're trying to cook like in colder weather, that's important. So with the sensor itself, it's going to give us an internal temperature of the meat, the target temperature of the meat, and then the ambient temperature on the grill itself. Now, this was early when I had just put it on, hence that lower value, but that number will rise as we get deeper into the cook from that perspective. So like I said, Meater, it's a good app, it's a good technology. The only issue I have with it is that range. And so what I'll be able to do is by going ahead and calling their API is it won't matter where I am. I don't need to be close to my phone. My phone will still need to be close to the grill to be able to communicate with the API itself, or sorry, with the probe itself. But from there, that information gets synced up to the cloud, and then I can go ahead and query that from wherever. So enough about sort of the Meater stuff, although it is awesome, but let's get more into the Power Automate, because I'm sure most of you are here for that, not necessarily the barbecue. Okay, so what I'm showing you here today is all possible through this API itself. So this is from Meater itself. So this is their GitHub page, and they've published this public REST API this past January 4th, 2021, in beta itself. And so there's a few things that you need to be aware of, but all in all, it is pretty simple, right? So number one is the endpoint, right? So that's the base URL that you're going to be calling. And then we've got a few different operations, which I'll show you here shortly. Now, the big thing that you do need to do is you do need to go ahead and log in order to get a token. And then once you have that token, it's essentially a bearer token that you can use on all of your subsequent calls to the API itself. Now, this will get a little bit tricky when we get into the custom connector side of things, and I'll explain why once we get there. But in order to log in, you'll go ahead and you'll provide a post message to the login endpoint itself, and then you'll use an email and password. So when you go ahead and register your device, you naturally, create an account within their ecosystem. You're going to use these credentials in order to do that. You're going to get a handy response, nothing too crazy. You're going to get your JWT token, which you'll then use in subsequent calls. Now, the next call is /devices, and this is going to go ahead and show you any of your devices that are currently connected, and it has to be currently connected. If it's not connected, you're not going to see anything here. And then whether or not you've got any cooks established, and all of the related information as part of it. And so you'll pass in that bearer token as part of your authorization header that you received from the login method previously called itself. And so we've got sample payload as well. Then what we can do, because this could list all of your various devices, and you can buy these devices in like a pack. Like I just have a single unit, but you can buy them in like a 4-pack, 2-pack as well. So it isn't unheard of that someone may have multiple of these going on at a time, especially if you're cooking multiple things where you've got multiple temperatures. It becomes quite handy. So I can totally see why their API reflects this. Then the next part of it is that we can go ahead and get the information for a single device itself. So once we've returned all of the devices, we're going to have a device ID, which we can then go ahead and call off of the device's operation itself. So those are the 3 operations that currently exist. Now what we'll do is we'll go into Postman here and just show you, live how these work. Okay, so I'm in Postman. We're going to go ahead and call the login operation itself. Here, all we have from a headers perspective is just content type application JSON, so you will need that. We've got our body, so we've got our email address, our password, and from there what we can do is go ahead and send that request, and then we're going to get a token back, with that bearer token that we would go ahead and use to call into the API. So the next operation we're going to focus on is devices. So this will go ahead and return all devices. Now in my case, I only have a single device connected, and this was what I had showed you, that screenshot. So we've got the beef brisket cook. It's currently in a started state. We can see the temperature, and so in this case, this is all in Celsius. So when we get into Power Automate, we're going to have to do some calculations here to go ahead and modify it, just knowing most cooks are done in Fahrenheit. We also have just like, how long the cookie has taken thus far. Now these values are in seconds, so once again, we're going to need to do a little bit of conversion from that perspective. And then last updated, this is going to be a Unix timestamp. So once again, another conversion, but this will be good. So this will be the basis of our, our situation, right? We're going to go ahead and monitor for temperature. If for some reason, it falls below our threshold, we can go ahead and alert on that. Certainly around the temperature, that's going to be quite important for us as well. Like we want that moment at 160 degrees Fahrenheit that we go ahead and we wrap this thing up. And then naturally, once you get closer to the end of the cook, maybe you want some notifications like, hey, we've reached 195. Hey, we've reached 200. Hey, we've reached 203, like get it off the grill. And so those are things that we'll have to embed within our flow itself. But overall, API, pretty easy to use and pretty straightforward. It would have been probably nice if you could just get like an API key just from the get-go, but that login works, nothing too complex there. So all in all, pretty clean API, and will be nice for us to go ahead and use. Okay, so I've decided I'm going to split this video into two parts. So next week I will go through this in more detail and show you how to do this exactly step by step. But essentially what I've done here is I have created a custom connector. I have created 3 different actions. So the login, get all devices, get device. And then I've also included a policy. Because of the way the login works, we can't actually use that, like from a security perspective, go ahead and provide an API key, because on the first call, you don't actually have an API key. It's only on subsequent calls. So what we're going to do is we're going to create a policy that allows us to override the authorization header on subsequent calls. And that's going to take more time to get into than just today. But note that I've got the 3 different operations in place, and I can go ahead and call it, test it from this specific interface. Now let's go over to Power Automate and our Cloudflow, and then let's walk through how we're going to set this up. So what we're going to do is we're going to manually trigger this. We're going to provide an input of target meat temperature. So at what time do I want this bot to stop running? Also provide a cook name just in case we want to have multiple of these running at the same time. Then what we're going to do is initialize a couple variables. So these are going to be floats for both our meat temperature and our grill temperature. Now I've included a couple fields for my username password, and naturally those are going to get passed into our login operation. And so this is our custom connector. If we head over to our actions, click on custom, we can find it right here after it's been published. I've also enabled secure outputs. Basically, I don't want my inputs and outputs like leaked into my logs. So I've turned that on from that perspective. So that's why you see the little lock. Then what we're going to do is we're going to go ahead and we're going to call the devices action or operation. And we need to pass in the token that we retrieved back from the service. Now, the token itself is a bearer token, but it doesn't include the word bearer. So that's why I'm actually including this here as basically to sort of prepend to my token itself. I feel like the new capabilities, the coding capabilities inside of custom connectors, I could probably solve this there. And so I might do that. That's another reason for deferring going too deep into the custom connectors, because I think that would just be cleaner. Not super pumped, but in the short term, this is what I need to do to get this to work. Now the next thing is I want a condition. So the idea is I want to kick this bot off, and I want it to run until essentially my cook is complete. Now what we need to do here is we need to make sure we have a cook that's active, right? I don't want to be calling and doing all of this logic when we don't actually have a cook that's in place. So once a cook's established, when we make our calls to the devices API, I'm going to get a result set back. So here I'm just checking to see, like, are there any devices that are being returned from the cook itself. And so in our, if we go flip over to Postman, this is essentially what we're looking for. We want to make sure that we've got a device, and that device, like if we have at least one device, then we've got a cook. If we've got no devices, there's no point continuing on with the rest of the logic. Okay, so at this point we do have a cook going. What I'm going to do is I'm just going to do a compose on the device name. So as part of that payload that is returned, we can have multiple devices here, right? So what I want to do is I want to just plunk off the first one. Now in my case, I only have one device, so I'm pretty confident in doing it this way. There might be other situations where you would need to do some additional logic to match up a device with a specific cook, but sort of I would leave that to you to implement. Once we have our device, then what we're going to do is just go ahead and call that device endpoint directly. I guess in theory we could have continued to call devices, but if you did have multiple cooks, you would want to focus on a specific device itself. Now, as I mentioned before in our in the earlier content, that the data that's returned from the meter API is actually in Celsius. And so that's no good for me. So what I want to do is I want to go ahead and I want to convert it into Fahrenheit. And so what I'm going to do is just use an expression here where I will go ahead and multiply the current value, the Celsius value, by 1.8. And then I will go ahead and I will add 32 to it. So that's just a common Celsius to Fahrenheit formula where I can go ahead and do that. I'm going to do something exactly the same when it comes to the converting the grill temp. I'll once again get the current value, times it by 1.8, and then add 3.32 using these expressions. Now, so what I've decided is that I want this to run until my cook is done. And so I've got a do until loop. And then what I did do is I did change the limits here. I said that we would do a threshold of 60 total turns. So basically this loop can run for 60 times before it'll shut down. And then the total timeout is 15 hours. So, you know, typically when you're cooking a grill, you're not going beyond that. You know, sometimes large briskets can take longer, but, you know, mileage may vary, but I think that's safe enough for my current situation. Then I've got the current time. So I just want to go ahead and get the current timestamp when I post this into Teams, because like this will get published periodically. So I just want to have the timestamp. I'm then going to go ahead and convert it. So I'll take the current time. The source is going to be coordinated universal time, UTC time, cloud time, and then basically convert it into Pacific. And then this is just the format string that I want. Obviously, you could choose whatever makes most sense for you. Then what I'll do is I'll go ahead and post this into Teams. And I'm just going to use the cook name from my trigger and put that in bold. Say the current meat temperature and the grill temperature, and then the current time. And then what I'm going to do is have a delay. Now, for the purposes of the demo, I'm just going to have 1 minute, but obviously this mileage may vary. You may want, you know, quicker intervals. You may want longer intervals. It kind of depends on sort of how long you want to wait between messages. So we'll get the kind of the current, the first sort of status of the device. Then we'll go to sleep. And then what we're going to do is call the device again. We're going to call that endpoint. And because we want to get the latest values so that we can then loop around and then provide them. And so what we'll do is, once again, we'll convert our meat temp based upon this call, not the call previously. And then also the same thing with the grill temperature. So that's why I'm using variables here, just because we do need some level of persistence from that perspective. Now, if you do recall at the top, our condition for the do until is that we want to continue to do this until our meat temperature is greater than our target, right? So if we said our target is 160 and basically based upon the latest call, we're now at like 161, well, then we want to break the loop. And so that's pretty important. We'll continue to loop based upon this criteria. And then just to make sure like we know that everything's confirmed and we've kind of exited that loop, I've got one final message that is outside of the do until. So let's just collapse this so it's clear. Once we've completed our do until, we're going to have basically like our last message to the user indicating that our current meat temperature has exceeded our target. Time to take food off the grill. This bot is now shutting down. So that's, just gives you a sense of how this works. Now, let's go ahead and I'll run this. So obviously, I'll do some pausing so that you're not staring at a blank screen here either. Okay, so let's go ahead, let's run this. I know my grill is running at about 111. The meat is at about 111 right now. So what I'm going to do is just put 113. We're going to call this brisket. And naturally, I'm not taking the food off at 113, but just so that you can see the experience of this while it is running. So we're going to hit our first loop. We should now have our first message inside of Teams. If we flip over to Teams, we've got 1:06 a.m. So the current temp is, 111. And so what we should see is maybe another message here representing sort of sleeping for a minute. And then we should see another message after saying that our meat temperature has exceeded, much like this message right here. So I'll go ahead and pause this and then we'll talk about it once it's done running. Okay, so let's just take a look. It's now completed, right? So we had set our target temperature of 113. And then so for the last, let's see, 5-6 minutes, this has been running every single minute, and we can see that the temperature is climbing up every minute. And then what's happened is now we've exceeded 113, so our bot is now going to go ahead and shut down. And so if we flip over to Power Automate, sure enough, we can see that our bot has shut down and that our cook has, at least we've hit that threshold. Naturally, we're not going to be eating brisket at 113, but, what I'll do now is go ahead and set it for 160. And at that point, I'll know to wrap. So that sort of concludes the technical part of this. Naturally, with Power Automate, and this is where it's like really cool, is like here we're using Microsoft Teams, but I showed a video earlier on the channel about using WhatsApp. So maybe I need to go ahead and wire this up to WhatsApp and send myself WhatsApp messages. I could send SMS messages as well if I wanted. And then another interesting opportunity could also be PVA. Like maybe I create a Power Virtual Agent and I go ahead and initiate a cook from Power Virtual Agents. I can check the on-demand status of my cook and things of that nature. So we'll have to see. Maybe we'll do more. If you folks are kind of interested in this stuff, do let me know in the comments, and I'll naturally spend more time if there is interest from this perspective. I know for some of you barbecue enthusiasts, you're probably interested, like, what does the actual meat look like? So I'm going to go ahead. We'll go down to my grill. I'll take a short video and include that in here. If you're not interested in seeing the semi-cooked meat, no worries. Just wanted to give you a heads up. And thanks again for watching this video. Okay, let's go ahead. Let's see how the brisket is doing. There we go. We're at about 114 degrees Fahrenheit. And so obviously if you're looking, you're not cooking. So we do want to get this closed again. One thing I will do is about every hour I will take some apple cider vinegar. That's what I'm doing right here. Spray it. Just help keeps it moist and prevents it from charring too much. Obviously you do want some nice bark, but this is something that I'll do every hour. So what we'll do is that'll be the last of this for today, and then once I've completed the cook, I'll go ahead and include what it looks like during next week's video. So a little bit different this week than last, but that's good too. So now you got a chance to see another passion that I do have, and that's barbecue. So thanks for tuning into this video. As I mentioned, there'll be part 2 next week. We'll dive deeper into the custom connector and sort of anything else I can think of from there, and also show you the end product of the brisket as well. If you're not following me on Twitter, go ahead and do so. Find me at Weare. Thanks for watching this on YouTube. Likes, subscribes, comments, always welcome. Thanks again, and take care. We'll see you next week. Go Cardinals.